in any consumer focused industry where the organization which is providing services is focusing on its customers and on its consumers and as to what preferences they have, it is quite likely that you will conduct a lot of market surveys. You would like to understand as to what are their preferences, and especially certain customized services that you might want to provide to high-end users of yours. Now, let's say there was a survey which was conducted that how many travelers would prefer breakfast in their bed. So, early morning, how many travelers would prefer breakfast in their bed versus people who might want to probably walk into the lounge, or maybe, in an outdoor catering scenario, probably walk up to a campfire or something to have breakfast. Let's say 77% said yes out of a certain population. So we are not necessarily mentioning as to what that population size is, but we are taking a proportion of that population, and then we are trying to predict as to within any other subset or any other data set or any other smaller sample size that you might have, how many people would actually prefer. And accordingly, you can go ahead and manage your, say, catering resources and other things, your logistics. So say you manage a tour of 200 tourists and they're traveling with you. So what's the probability that 80% plus? So if it is 80% plus, that means you probably will have to cater for it. It is something which is definitely preferred. So you go ahead and take that ratio. Say 80% plus will want breakfast in bed. So the sample size is 200 over here. The population is not necessarily mentioned. And you go ahead and take that population proportion, which is pi, as 77%. From where? From the earlier research that somebody has done, wherein you got 77% over here. You go and input that. 80% is what you're looking for now. And you go ahead and get a probability of higher than 15.67%, which is quite a decent probability in case you want to go ahead and cater for such a contingency. Now, how did we do this, and what does this probability actually mean? So what we are actually doing is we are going ahead and doing estimation. And estimation in statistics is extremely important. And there are certain characteristics of an estimator which have been listed out in most literature of statistics. And the very first one is unbiasedness. Unbiasedness means that the estimator should not be biased in a certain direction. Now, what we are trying to do with the estimator is that the estimator, which is a statistic for a certain sample size or for a certain sample, with that we are trying to estimate the population parameter or a characteristic of the population. From a smaller number, we are trying to predict how a certain characteristic would be displayed in a larger population or in a certain population parameter. So unbiasedness is definitely required. Why? Because once you're taking, say, a mean of a sampling distribution, the statistic should be equally flexible to either go above that mean or go below that mean to a certain extent. Now this brings me to the second point of discussion, that is point estimate versus the interval estimate. So if you were to take a point estimate, you could either say that yes, if it is this particular point that we are looking at, then you could either be right or you could be wrong, and which is not a very good, it does not give much confidence to people when you say that. So let's look at another situation. Let's say your tires wear out over a period of time. So you have different organizations like the MRF or say, Apollo Tires and various other organizations who are trying to understand as to when their tires will wear out over a period of time. And if you were to go ahead and say that yes, we have gone and done certain calculations basis which we have estimated that a tire will wear out after exactly 36 months after it is a new tire set is installed or a new tire set is put on to the vehicle. That does not sound like a very, very realistic estimate. A realistic estimate might say any time between 32 months to 38 months, the tires would require replacement. Now that is an interval estimate, and that's the reason why interval estimates are preferred, is that the efficiency is not compromised. The consistency can also be achieved to a higher extent with the interval estimates. And sufficiency, which actually means there is so much of information provided in the particular sample that no other estimator can extract that much information. So let's say you go ahead and do a certain survey and you say, I have created an interval estimate, and my interval estimate says that between 34 to 38 months is when a tire should be replaced, a set of tires should be replaced. So is that sufficient enough, or will the organization or the individual who's gone and sought your opinion, will they have to look at some other survey? Will they have to look at some other, estimators? So that should not be the case. So it should also be sufficient. Now let's look at another example. Now here is a survey which says, how many travelers need internet while on vacation? So most people who are on vacation probably would not want to access the internet. But in a certain population survey, 45% said yes, we would definitely require internet even while we are on vacation. So again, you are the tour manager and you've gone ahead and organized a tour for say 50 tourists. And what is the probability that 40% plus tourists will need internet access? So let me change this to, why 40%? So what we are looking at over here is 40%. That's what we are calculating. Let's look at a figure of say 90%. So how does this probability vary? So from 76%, where does it go? It goes to 0%. Why? Because the population itself says that 45% said yes. Right? So that does not make sense. So you will not get a probability higher than that, is what we are trying to justify over here. But again, this is a point estimation method. You might not want to do this. You might want to get a range. You might want to get a range wherein you say that I want to understand between these two particular ranges, between these two particular values, that is the sample proportion P1, which is 40, and 50, how much of my values would lie? So between what is the probability that my values would lie between 40% and 50% over here. So you can see I have picked up those particular percentages from the formula. And again, depending on the sample size taken, now these two are exactly the same over here and over here. These two calculations are exactly the same. The only difference is of the sample size. And when you see what we've done is we've gone ahead and over here we had 100 and over here we have 400. So the sample size has jumped 4 times. That is how much it has increased. Now what has happened to our standard error of the proportion? The standard error of the proportion, or the standard deviation of the proportion, the standard deviation of the estimators, the standard deviation of the sampling of the estimators of the proportion, what exactly has happened over there? It's halved itself. Here you can see it's gone ahead and halved itself. So when you increase the size of the sample that you're taking, when you sample as many times as possible and sample to a larger extent, the standard error of the proportion, or the variance amongst the means of the proportion, or of whatever estimator that you've taken. We've taken proportion over here. Otherwise, the deviation between the means, the deviation between or in other words, in simpler terms, the standard error of the mean, the standard error of the median, the standard error of the range, all of these will reduce. They will the calculations of the mean, or the values of the mean, will come closer to the population mean. And the population mean over here, okay, in this particular calculation it's not been given, but the population mean would be the mean of the population, the average or the central point of the population, and it will also be the median of the population if it's a normally distributed population. But even if it's not a normally distributed population, then also in that case the sample of the proportion will become much more closer, will co-lie or will coexist with the population's mean if the sample size is increased.